Hello and welcome to this video tutorial in which you will learn how to build a basic model with trains created according to a timetable, with boarding and alighting passengers that walk to and wait at a platform. I will show you how to build this very simple model of one platform where so-called transport elements stop on both sides of the platform. You will see that like agents, transport elements are created with a generator. Boarding and alighting passengers are easily created by linking the agent generator with the transport generator. The platform is always modeled using a walkable area. When this element is drawn in the height layer, the complement becomes non-walkable space. Transport elements are drawn alongside the platform to define stop locations for transport element. It is found on the special toolbar. A transport generator determines at what time and at which network location a transport element arrives and leaves. The generator is defined in the transportation input. The first two pages of the transportation input form are used to define different types of transport elements. The capacity, physical dimensions, and door settings can be used to create different subtypes, which are the carriages. On the types page, a metro or large train can be defined. The defined subtypes can be selected and added to the list. The number of carriages of each subtype can be set. Like the agent generator, the transport generator consists of an arrival list and general settings. I added a second row for the train in the other direction. I disabled the code boxes to copy the row. If this option is enabled, you can open a list of predefined options for the cells in the table. The train should have a unique ID. Later, this ID will be used in the agent generator. I also give both trains an arrival and departure time. If several transport types have been defined, for example a train and bus, they can be selected in this list. Here I only have the default transport type. The network ID determines at which transport network the location drawn in the environment the transport element will stop. I changed the direction of the train that stops at the first transport network. The entry and exit side are both on the left side of the transport element. Note that left can be selected and is also indicated by the value 1. The stop location of the first train needs to change. A percentage indicates where the front of the transport element stops on the transport network element. The percentages are visualized along the transport network. On the general page, I make sure that the timetable is repeated every 10 minutes, and the number of times to repeat is limited. A complete arrival list for the whole simulation is created at the start. Therefore, it is important to make sure to either limit the repetitions or the number of transport elements. Boarding agents will be created at a certain time before a transport element arrives. Therefore, an offset time has been set for the transport generator. Because the generators will later be linked, the same offset needs to be used in the agent generator. I add 2 entry-exit areas and run the model. The trains stop at both transport networks, according to the arrival pattern I have set. To create boarding and alighting passengers, you need to define the routes. Besides entry and exit activities, you need a board and alight activity and a wait activity. The platform is typically the waiting area for boarding passengers. It is not necessary to draw a waiting area that covers the whole platform. Just draw a simple waiting area. Select the option Wait until triggered for the activity time. For location approaching, choose the first special logic for transportation. This will make sure agents wait near the door they will use. Now I can define the wait activity that takes place at the platform. Just select Waiting for the type. In this example, I only have one waiting area, so I can select All. I can use predefined transport logics for the pre- and post-condition. This will make sure an agent skips the waiting activity if its train is already at the platform. The board activity should take place at the transport elements. Therefore, I select as type Transportation. For the location assignment, select the user-defined logic Transportation Boarding when transport generator is assigned. For the alight activity, I change the location assignment. Select the logic Transportation Deboarding when transportation generator is assigned. Here I have created the board and alight routes. Finally, I need to create 2 agent generators, one for the boarding agents and one for the alighting agents. It is important to use the same repetitive settings as for the transport generator. Do not forget the offset time. For this, a predefined transport logic can be used. I also need to link the agent generator to the transport generator. In the agent's arrival list, each row should create the agents for the corresponding transport element defined in the same row of the transport generator. For the creation time, I select the predefined transportation deboarding logic, which is the departure time of the transport element. For the number of agents, also select the transport logic. It will create agents based on the capacity of the transport element. For the activity route, select the alight route. With the transport ID, you assign the agent to a transport element. Here, I select the unique ID given in the first column of the transport generator. For the second row, I can reuse most settings. The only difference is the transport ID. Here you see the transport element arrive, with passenger alighting and walking to the exits. The generator for the boarding passengers is very similar to that of the alighting passengers. In the list, I need to update the activity routes and select another creation time logic. I adjust the creation time of the agent prior to departure to 4 minutes. In this case, the agent is created 2 minutes before the transport element arrives. On the general page, I only need to change the name and the time setting. To make sure the agents are created before the transport element arrives, I subtract 2 minutes from the offset time logic. I use a uniform distributed delay time to spread the release of the agents in the model over a time period. Here you see the result. The red and fuchsia colored agents are the boarding agents. With a few changes to the visualization settings, this is the 3D simulation. Using the special transportation tools and elements, you can build train stations like this, but also model bus stations, airports, and any other location where transport elements arrive according to a schedule. Thank you for taking the time to watch this video.